Okay, so in this video we're checking out the Tomoquads Katana V2 build. So this frame is might still be on sale. I'm not sure if the code will still work. It worked yesterday on Labor Day. I think the code's Labor 15 for 15% off the frame. You might want to see if it'll still work or not. I'm not 100% sure. But this is an ultralight 5-inch frame, and as you guys can see, it looks very similar to the Dave C FPV design, the 4-inch, I think it's called the Explorer LR. Now, Tomoquads did tell me that this design was actually based off of his original Katana V1 design, which is I think was a 4 and a 5-inch with folding arms, which kind of similar. I think I had also a dead cat style, and so he redesigned it so that it would be lighter but not have the folding arms. Now, I never reviewed the V1. I'll just put a picture up here of what it looked like. I mean, these are all dead cat style frames. The dead cat style frame is basically the rear arms are pushed back a little bit and pushed in, and then the front arms are pushed further out and the motors are further back so that the props don't show up in the view of the FPV feed. Now, I've flown a lot of dead cat frames in my time, and I don't really like the way they fly too much. They're hard to tune, and in windy conditions they can present problems in terms of the tuning, in terms of the flight characteristics. But it is a good platform if you want to do like HD video. If you're just cruising around, if you can get the tune right, you can get some pretty smooth video. I think a lot of long range frames are based on the dead cat design, like the 7-inch. I think from 4-inch all the way to 7-inch. So this is a pretty typical style, the dead cat style, for cinematic long range type of flying. Now this build is pretty straightforward. Basically put the frame together. I put this is the JHEMCU 30 amp all-in-one flight controller. So it's a basically a whoop style all-in-one flight controller and ESC combo board. And it's pretty popular. I think that the early batches did pretty well in terms of reliability. I'm not sure if this is an early batch or a later batch. I've heard that some of the later batches had some issues, so not sure how reliable this is. But there's so many of these boards out now, coming out from all kinds of different companies, and you know, whether or not these are reliable or not, it's hard to say. It really has to do with your flying style and how rough you're going to be on the equipment, because basically what happens is if you have a voltage spike, if like the props are stuck somewhere, if you're trying to do turtle mode, for example, or if you crash really hard and the prop gets stuck, if a current spike or voltage spike goes through the board, it'll pop an ESC. And the reason is it's a single board and there's only so much space to put all this copper, and so when a huge spike comes through the board, it'll pop an ESC or a FET. So if you're one of those kind of guys that are really rough on their equipment, and you're probably going to pop an ESC from a crash, I would suggest not doing the whoop style all-in-one build, but instead doing like a stack. We have a separate 4-in-1 ESC and a flight controller. It's going to be a little bit heavier, and obviously the build's going to be a little bit different, but that's what I would suggest if you're going to crash a lot. Don't build with these whoop style boards, because a lot of people that crash a lot tend to burn the ESCs on these particular type of builds. So basically, I mounted the board. Then I mounted the motors here. These are the Beta FPV 1606 25 50 kV motors. So I mounted the motors and I soldered them to the board. And this is a DJI build here. You know, it's got the Eachine Nebula Micro, and basically this has the updated lens. It's got a bigger lens with a 165 degree field of view. So with the 16:9 only aspect ratio on this camera, the larger vertical field of view is better on this one, in my opinion, than the standard Nebula Micro. So if you want the larger field of view, get this version. And I think it's also on promotion right now. It's like 125 with the Vista Air unit. So if you get by itself, I think it's like 29, so it's not bad. Anyway, this being a DJI build, is pretty easy to put together. Once you've mounted the flight controller and the motors, you just have to solder on the Vista unit to the flight controller board. Since I'm using the DJI controller, I'm not going to be soldering on a separate receiver. So basically just 6 wires to solder to the board, and then you just mount the Vista in the back here. And it's pretty straightforward there. Just 4 screws in the bottom. and that mounts the Vista, because there's a 20 by 20 back here and a 16 by 16. So if you're building this as analog, you can put a 20 by 20 VTX back here or a 16 by 16 VTX. And also this frame will take whoop style as well as 20 by 20 or 16 by 16 stacks in the center part here. And then you've basically micro style cameras here in the front, 19 millimeters, or the DJI 20 millimeter cameras in the front. So this frame did come with a bunch of other TPU parts here. Tomoquads does make a lot of TPU parts, little accessories for his frames, and I did not want to install all this stuff because of the extra weight. But if you go to the link, you'll see how the arm bumpers look on here on the end. They will obviously protect the carbon better in crashes if you crash a lot, but I wanted to not have that extra weight on there. And let me just give you all these weight measurements here. So here's the quad, no battery, everything on there. It's 175.2 grams, but you know, all of this extra TPU stuff is coming in another 14.2 grams. And one of these parts here is this GPS holder, and it goes in the back. If you're going to be using GPS for like long range or something like that, that's going to go in the back here, and that's going to add a little more weight. Of course, you know, if you do GPS build, you're going to add more weight for the GPS as well. And also you could probably want to do some sort of HD camera in front here. I will probably make something for this, for like the GoPro, naked GoPro light in the front here at some point. I actually have two of these frames. So I have another one, haven't even put this together yet. This one's in black. And I'm going to be doing some additional motor testing. This is just basically the first video of this frame you'll see. You're going to see this in other testing videos because someone wanted to see this 1606 motor on a 5-inch prop, and I didn't think it was going to be an ideal combo. I think that this motor, if you can do a 1606 motor, probably better to do this on a 4-inch or like a 3-inch Cinewhoop. This bigger 5-inch prop is a little bit more difficult to control for this smaller motor, and it's not necessarily because this prop is heavy. It's a 5-inch. This is an HQ 5x2x3 prop. It's not super heavy. I think it has to do with the fact that it's has something to do with momentum or inertia of this extra long prop, and this motor doesn't quite have enough torque to control it, especially if like it's being pushed around in wind and stuff. You'll see it kind of bounce around in the wind. I did a fair amount of tuning on this, and I think you could get it a little bit better if you maybe increased your P and D gains some more, but then, you know, I'm kind of worried that it's going to be pushing the motor a little bit too much, maybe getting it too hot. But, you know, I honestly think that if you're going to do 5-inch and this motor, you probably are going to have a hard time tuning it. I would recommend going to a bigger motor. Now, let me just explain here. Let's show you here, like some weight differences. So I may do a bigger motor on this one. Actually, in fact, I'm going to do a bigger motor on this one. I'm going to be testing out some 2004 motors. This one's a 3000 kV from Beta FPV. And I also have the Brother Hobby motors coming as well. But this motor here is about 16.6 grams with the wires. But then like the 1606, this is the 1550 kV version. So that one is 15.1 grams versus 16.6 grams. So it's about 1.5 grams more per motor for, I think, a motor that's going to have a lot better time controlling that prop. So what is that? About 6 grams total weight added over this build. We're talking 175, so 181 grams with the 2004 motors. So this will be in a future video, of course. You know, and I'm going to be testing this motor as well as the Brother Hobby motor, and I'm going to be doing an identical build on this one. So we do some sort of pseudo side by side later on. But yeah, so this isn't the final build or anything like that. This isn't even like my suggested build. I think that if you were going to build this, don't get the 1606 motors. Get these instead. I'm pretty sure these are going to be way better, and the weight penalty is only about 6 grams. So this is probably the motor I'm going to recommend anyway. I already know that. I mean, as long as this motor doesn't blow up on me, this is probably the motor to get anyway, and you'll see that in a future video. Okay, last thing here is the battery I use. It's the Kodar 4S H50. Kind of looks like a G&B or the Owline. That's what people have been saying about these batteries. Performance seems to be in line with that as well. Perhaps they're coming from the same factory. Maybe it's reprint. I don't know. All I know is that this is being sold on Amazon and on their own site, 7-7. I'll link this down below. I mean, this seems pretty typical compared to a lot of other 4S 850s, and it's perfectly fine in terms of weight. This quad can handle that no problem. So if you are looking for a battery for this particular quad, this one is fine, and it fits on there. Just, you know, it doesn't take up too much space. So, and also this frame here could bottom out the battery. See, there's slots here on the bottom as well. Not sure how that would fly, but if you wanted to put a much bigger battery on the, you can bottom mount it. Say like a 4S, like the 18650 lithium ion cells. That could be also a possibility if you want to fly with a really big battery and have like massive amounts of flight time. I mean, even on this 4S 850, I'm pretty sure you're going to be getting minimum of 10 minutes of flight time, possibly more depending on your flying style. Okay, so that's going to do it for this video. Here's the flight footage, and of course I'll have more content on this frame in future videos, so stay tuned for those, and I'll talk to you guys in the next one. Alright, so that's a lot better. Had to bump up the PIDs a little bit, and pretty sure it's because this thing is really super light. Yeah, it's very floaty. Doesn't feel like a real 5-inch. So I'm flying a 4S 850 on this, and the wind's starting to pick up. And you can kind of see the limitations of the 16. Here's the 1606 motor. This is probably going to be a very efficient setup with these HQ props. These are the 5x2x3s. Begin cruising with a little bit of light acro thrown in. Very floaty though. It doesn't drop very fast at all. Not bad overall though. The PIDs are pretty good. At least when it's not, wind's not blowing. Let's do a little cruising around here. So this has the new E-Sheen version of the Nebula. Yeah, it's very windy right now. Much wider field of view with the 1.66mm lens. Yeah. But it's got the same image. I did alter it a little bit, the settings, to the ones in my settings video. What do you guys think of the settings here? Saturation is a little hard to say. The colors are shifted over to the yellows, I think, a little bit more. I'm not sure if I can change that or not. But I really like the much wider field of view of this lens on this camera versus the standard lens. I might have to switch a couple of my other nebulas over. nebula micros. And you just can see a lot more. And the vertical field of view is much better too, so if you want to get closer to the ground, you do have a little bit better feel with this lens. I definitely like it better than the standard lens. I don't really have a whole lot of camera tilt on here, but let's see if I can go a little bit faster. Went down to 14.9 volts. This is a 4S850, but it wasn't fully charged, I don't think. 15 volts. I think we got some sprinklers running over here. Alright, so that's the end of the battery, close to it. 5 minutes of flow time. I think you can probably get a little bit more if you fully charge the battery. I think I did spend a little of the battery doing some PID tuning here at the beginning, so that's why the voltage was a little low. Still not bad. 14.8 volts, 2.7, over 5 minutes of flight time. Definitely go way longer with a bigger battery. Definitely go bigger for this 5-inch. No problems. Let me know what you guys think.